Hi, we have finally come to the last chapter in AMath, Proofs in Plane Geometry. Very importantly, we're going to make use of all the concepts that we have understood about geometry and actually apply it in the AMath topic itself. There are four various methods in doing our proof itself, but today we're going to touch on method 1, basic proofs in plane geometry. And the method that I'm going to use is denoting the unknown. This is a very useful method which I've shared with you all previously. We're going to recap again today. Very importantly, before you start on the question, you must always make sure you read the question carefully and mark out all the given information on the diagram and deduce anything that you can do. Without further ado, please pause this video for 1 minute and do your necessary marking before you come back to the video again. Okay, assuming you have done your marking, I'm going to do likewise together with you as well now. Okay, first thing, you have bisector GM of angle AGH. So in this case, since GM is the bisector of the angle, it means these two angles must be the same. Alright, similarly, HL is the angle bisector of angle DHL. So, angle LHG as well as angle LHD must be equal. Alright, and you have seen over here that the two bisectors are actually parallel to one another. Without further ado, I'm going to write down that they are actually parallel to one another. Okay, if you remember correctly, whenever two lines are parallel, there are a few things you can make use of. You can make use of the Tsai theorem. Tsai meaning C standing, corresponding angles are equal. Alright? Next, A, alternate angles are equal. Last but not least, the interior angles are equal as well. Okay, this is based on the Tsai theorem. So with that, it also means that if now I would like to prove that AB is parallel to CD, I can make use of either one and the converse is true. Either using corresponding, alternate or interior angle. And take note, our end in mind is AB is parallel to CD. As you can see over here, AB is parallel to CD. Okay? With reference to the diagram, you can see very clearly I would like to prove, based on whatever is given, that most likely AGH could be same as GHD, being alternate angle, and we are done with it. How do we do that? Now we need to actually write it out step by step. Okay, and helping steps are actually given to you. First thing, we need to denote. It's very difficult for us to keep writing a 3-letter angle. So rather than doing that, let us denote the unknown. Okay, let angle AGM be X. As you can see, the moment angle AGM is X, it's very clear cut to you that this angle over here must also be X. Okay, and based on the fact that the two lines MG as well as HL are parallel, it means that this angle must be X as well. Use of alternate angle over here. Last but not least, because of the angle bisector, this last angle over here will be X as well. Then we are more or less done. So this is our approach. We're going to put that down in words now. Okay, with reference to your own diagram, okay, you can see that AGM is equal to angle X. Similarly, MGH must also be equal to X. Okay, because of the bisector itself. Now, MGH is equal to GHL, as I have said previously, because of the pair of parallel lines, and the reason why these two angles are the same is because they are alternate angles. And in this case, because HL is the angle bisector, it means that GHL as well as LHD must also be equal, which is equal to X as well. Now, can you see that angle AGH is equal to 2X? Angle GHD is also equal to 2X. Let's write that down as well. And since both those angles are equal to 2X, we can conclude AB is parallel to CD. Reason being, when those two angles are actually equal, I'm also making use of the concept of alternate angles. And there you have it. The first question is neatly done. Okay, let us move on to the next question.